Hello friends, in today's question, a particle of mass m moving in a circular path of radius r with a constant speed v2 is located at point 2r, 0 at time t is equal to 0, and a man starts moving with the velocity v1 along the positive y-axis from the origin at time t is equal to 0. Calculate the linear momentum of the particle with respect to man as a function of time. So we have a particle which is at, let us suppose this is 2r, 0. So we have 2r, 0. This is the location of the particle, and it starts to move with the constant velocity v2, speed v2 at time equals 0, and at the same instant a man from the coordinate 0, 0 starts moving along the y-axis, and we have to find out the linear momentum of the particle with respect to the man. So in this case, let us say that we can, using the vector notation, we can say that linear velocity of the man it is given as v1. So we can write this as v1 along the j vector, and similarly we can say that linear velocity of the particle it is given as v2. So we can say v2 will be equal to v2 multiplied by minus sine of theta j, sorry, theta I. Let me write it again. v2 can be written as v2 minus sine of theta unit vector I plus cos of theta unit vector j. And in this case, the theta is the angle made by the v2 velocity. Suppose at some instant it will be something like this. So we are going to have theta, and this will be v2. And we already know, if omega is the angular velocity, if omega is the angular velocity, then we can say omega is equal to v2 divided by r, and we also know that angular displacement theta is equal to omega multiplied by time t. Now this displacement, here the time t is equal to 0, and here t is equal to given as t. So theta is equal to omega t. We substitute value of here as omega 2 upon r. Therefore we can write that our angular displacement theta is equal to v2 upon r multiplied by t. Now we substitute, let us call this equation 1 and this equation 2. Now using equation 2, we get v2 is equal to v2, and we get minus sine of v2t divided by r I vector plus cos v2t upon r j vector. Now we are supposed to find out a linear momentum of the particle with respect to man. So can say the linear momentum of the particle with respect to man, linear momentum of particle with respect to man, that it is denoted as LPM, which will be equal to the difference in the momentum v2 minus v1, and mass you can say you can take as common. Now we substitute value of v2 and v1. Therefore we can say linear momentum LPM is equal to m, and v2 is given as minus v2 sine of v2 t upon r plus iota plus v2 cos of v2 divided by r j unit vector, and minus v1j bracket closes. Now we just rearrange the equation by combining the unit vectors. We can say that our linear momentum of particle with respect to man will be given as m. We get this as minus v2 sine of v2 t upon r I unit vector, and here it will be j unit vector is common, so we get v2 cos of v2 t upon r and minus v1 bracket closes. So this is the linear momentum. This is the linear momentum of the particle with respect to man, and it is asked as a function of time, as a function of time. So this completes the question. Thank you.